All right, good morning and happy Monday. I'm planning on doing LeetCode contest 329 from last Saturday. It is 5:24 in the AM and it is time to shine. So here we go. Share my screen. And it's time to shine. Here we go. 329. Open these guys up. Okay, plus and minus each one already. While in. Actually, let's do this in Python 3 first. Python 3 is a little bit more simple. And let's just call this thing X. S equals string formatted this guy. And then for each character in S, we do plus or minus each. Let's see. So return the sum of, let's see. So X if I, not I, modulus 2. So if it's even, else negative X for X in S. Let's do int something like that. Oops, sorry, for X, IX in enumerate. Oops, enumerate S. Okay, 4, 1, and 0 looks good. All right, nothing too fancy. Okay, so let's do this. F, so in and there. Right, basically just shorten this thing up into a lambda. Looks good. All right, that's cool. Let's post it. All right, view solutions. Yeah, I mean, form the simulation. Right? I don't know, whatever. JavaScript. Right, read the problem statement if you want more details. And this one's pretty straightforward, right? Okay, and then we'll do transform this guy into a string. Split it into an array of characters. Map. A modulus 2. Negative number X, otherwise number X. And then use Lodash for the sum. Oops. Don't want that star there. Okie dokie. Looks good. That's cool. There's JavaScript. Kotlin be next. All right, so in that two char array map indexed ix if I modulus 2 is equal to 0, then it's positive x dot 2 int, else negative. I think -1 times x dot 2 int should work. Some, oops. Whoa, unknown error. What the heck? Oh, that does not look right. 52. Two char array map index x. Oh, it's the ASCII ordinal value. X dot 2 int minus 0 dot 2 int. Hold on. Map index dot map it minus 0 dot 2 int. All right, so offset it by the ASCII ordinal value of 0. Oh, no way, really? Oh, this is way off. What the heck? Index. Two char array, map indexed. If it's evenly divisible by 2, it's even. Otherwise, -1. Let's do this. Oops, hold on. Go back to this guy. We'll just do a debug print. Just keep that guy there. And then s equals this guy. For x in s dot 2 char array. With index sign I or sign x. I'm trying 0 at the end here. Oops. Okay, let's just oops. The little brackets around that to destructure it. Come on. Okay, 0, 5, 1, 2, 2, 1, right? This index and the value. So that looks right. Index value. If I modulus 2, 0, so if it's even, then let's do this var t is our total, return the total in the end. T plus equals x dot 2 int. Oops, else t plus equals -1 times x dot 2 int. Okay, and then we'll print t. Let's just do this first one. First test case. Should be 5, -2. It's 5, 3, 3, 5, 2. The ASCII ordinal value of 0 is 48, I believe. Yeah, so t minus 0.2 int times the length of s. That's not right there. What the heck? How is this one? Oh, okay, I see. Okay, I see. Okay. So this one is a little bit off in that I gotta do this. Okay. To end here. Okay, you can't just do that calculation at the end, right? Okay. I think that makes sense, right? Okay, I think that should be fine. Right? Yeah, okay, that's cool. All right. Looks good. Okay, so that should be accepted. Oops, probably want to get rid of the print line. Okay, so calculation was a little bit off for the Python. Let's do this about map. Let's do dot map hit dot two int minus 0.2 int. So do that first, and then map index this and that. Okay, that looks good. Right? I think so. Yep, that's cool. All right. Kotlin. Okay, then Rust and C++. We'll save Rust for last. Let's do this. O string stream. Oh, actually, string stream. Put with in and then output it as a string. Stick in there, pull it out into S, and then T0. Or each character in S. Turn T at the end, T. Just use for index. If not, I modules 2, so it is even. Then T plus equals S of I minus 0, else T plus equals S of I, is it a, yeah, okay, so negative S of I minus 0, right? That's good. Oops, hold on, I think clean this up a little bit. I modulus 2, otherwise. There we go. Oops. Yeah, nothing too fancy, right? Stick it into a string and then just do each character of the string. Okay. And do Rust next. Okay. Coffee time. Need a little extra coffee for Rust. Rust always gives me a hard time. Um, T equals 0 and T at the end. So we'll do this procedurally first and then functionally next. So that S equal string or not format. So each character C and S dot chars dot enumerate. Just print this out. C. Okay, we'll just debug the first one. Okay, 0, 5, 1, 2. All right, that's good. Okay, so if I modulus 2 is equal to 0, otherwise, so t plus equals c as u8 minus 0 as u8. Turn t as SI32 at the end here. Negate this thing. Whoa. No, apply urinary. Oh, we're making an I8, so it has to be unsigned rather than signed, right? Or signed rather than unsigned. Looks good. Oh. Oh, come on. Looks good. Okay. That's cool. And cleaned up a little bit. Okay, so we'll make this functionally enumerate. Oops. Map indexed character if I modulus 2 is equal to 0, so it's even, then we'll do this guy. Otherwise, we'll do this guy. Actually, we'll clean it up a little bit here. Dot sum dot unwrap. Oh, it must be known. Oh, does that work? Oops, I32. Does not like that. Some I8 does not. Okay. Oh, okay. Well, let's just make these I32s then, right? Someone I32, just copy and paste this. How about boom, boom, boom. Oh, wow. Oh, Kidoki. Thought return an optional. Okay. Looks like it's okay. All right. So that's functional to procedural. And I think we can clean this up a little bit, right? So we can map it. This first, right? Call X to be consistent with our other code. Dot enumerate dot map be X, otherwise it'd be negative. Oops, hold on. Pick up X. Okay, I think that looks right. Looks good. Okay, a little bit shorter, right? Okay, whatever. It's good enough. Doesn't have to be perfect, but it's cool practice. Okay, perform the simulation. Right, okay, and whatever. We'll just write it down, right? Convert the integer into a string. And for each ith character of the string, let's see, then I guess accumulate the sum of each ith character of the string. Negating odd index values. Wait, okay. Should be good enough. Convert the integer in, I guess the input integer in into a string. Then accumulate the sum of each ith character of the string, negating odd index values. Then whatever, it's good enough. Okay. Read the problem statement if you need more details, right? Okay. All right, so that was Q1 done in 22 minutes, 1 hour, 8 minutes for Q2. All right, it is 5:46 a.m. in the morning. And we have 1 hour, 8 minutes remaining in the contest. Okay, so what is K equal to? What is K? Sort the students by their scores in the K. So 2, 0, 1, 2. Sort it based on this guy descending. Okay. Sort it based on the first column. Okay. Okay. A dot sort key equals comp to key lambda a b. Okay, so a sub k. Actually, we want to start descending. B sub k minus a sub k. Turn a. Okay, let's see what happens here. 7, 5, 11, 2, 5, 6, 3, 4. Okay, that looks good. And then we can clean it up a little bit. All right, okay, that took about 1 minute. About 1 minute for implementation. Implementation in Python 3, which is AC. Yay! Okay, and we can clean this up into a one-liner, right? Nothing too fancy. Let's get going. It'd be awesome to have some time for Q4. Okay, A dot sorted. So it's in place. Sorted with this guy. Looks good. Uh-oh. List. Oh, really? A list? What? Oh, hold on. Sorted A. This way. Yeah, okay. That looks good. Looks good. Cool. Okay. 2 one-liners in a row. Let's post this in the other languages and move on. View solutions. Sort the input. Let me see. Sort the rows of the input matrix A by the K column. guess, yeah, yeah, that looks good. Good enough. Nothing too fancy. JavaScript 3. Rust. Stick this here. Okay, coffee break. Okay, use the analog images here real quick. Okay, A dot. Sorry. P B sub K minus A sub K. And return A at the end. Looks good. Alrighty. Too fancy. So this does require understanding of the operator precedence as well as what happens in JavaScript. So it basically returns this guy. Okay. Dokie. I A K. Sort each row of the input matrix. Row. Oops, hold on. And turn B sub K is less than A sub K. Take K by value within the lambda. Turn A. Oops. Go. Okay, that's good. That's good. Okay, Kotlin, and then see the best for last is the rest. Let's turn this into a lambda real quick. Yeah, A dot sorted in place. A dot sorted. Sorted. Is it sorted by? The comparator. B sub K compared to A sub K. I think that works. Uh-oh. Type inference, yeah, sorted by error function return. Holy cow. Tray. K doesn't know. Capital K. Ordered. Well, sorted with. Is it sorted with? No, you want to sort it with the comparator. Ah, what is this thing saying? Cannot be applied to comparator was expected into a comparator. Oh, I see. Okay. Type alias. We'll just call it VI. Oh, it's int array. That's basically a vector of integers, right? Does that work? No, it's not happy. What is this thing saying? Achiever arguments. Type mismatch. Inferred type is this, but that guy was expected a comparator. Does that work? Sorted with this comparator. I might have to look this up. Oh, compared unresolved reference compared to. Oh, I need a uppercase. Big money, no M's. Oh, what is this? None of the following functions can be called with the. What the heck? Really? Oh, lowercase a. Right. Want to compare the rows. Big money, no whammies. Oh, yeah, that looks good. Yay. Okay, there's Kotlin and then Rust. Okay, A, K, type, oops. I32. Vector, integer, 32s. Case I32, BBI, okay. Turn A at the end, A dot sort. I don't know if that works or not. Expected 0 arguments. Sort. Is it sort with? Sort by? I forget. Hold on. No sort with. Is it sort by? There's no sort by. Okay, hold on. Rust vector. Let's look this up real quick. There's no sort. Sort underscore by. Whoa. Use size. Okay, fine. Like k equals k as use size. Be really nice if LeetCode passed in the parameter as a use size. Ordering. Oh. Is this right? Compare to. Uh-oh. This is not found in I32. Sort by. Sort by. Partial compare. Oh, the unwrap. Okay. Really? Partial, oops, partial comp. Borrow this guy. Come on. It's mutable. Big money, no whammies. Yay. Okay, I always save the best for last. That rush gives me a hard time. Okay, nothing too fancy. Right, sort the input, sort the rows of the input matrix A by the kth column. All right. And we have 55 minutes left in the contest. It is 6 o'clock exactly in the AM. And we have 55 minutes remaining in the contest. Okay. Okay. Maybe the count of the ones equals the count of the zeros, because I can be turned on. Well, this is turned off, but we have to have a 0 and a 1. Right? I think it makes sense. The count of each, count of ones equals count zeros between source and target. Right, I think that makes sense. S and T. Okay. Return the length of each character. C for C and S if C is equal to 0 equals the same thing for T. If the zeros are equal, then the ones are also equal, right? Whoa. All right, yeah, we gotta have the generator do its thing here. Into an array, looks good. Oof, okay, that is not correct. Okay, my gut intuition was wrong, it seems. This is incorrect algorithm. Expected false, or output was false, but expected to be true. Okay, so this guy's ass. Hold on. Oops. S is this guy. T is that guy. Okay, how many ones do we have here? Our zeros. We have 4 zeros. 5 zeros. Okay, so 4 zeros and 3 for 5 ones. One, two, three, four. 1, 2, 3, 4, 5. Right, 5 zeros and 4 ones. I see. Okay. Is it or the other way around? The ones equals the zeros? No. Okay, so this one, J, right? So I or J. So if it's, what are the use cases then, right? If it's 0 and 0, right, simultaneously. there's 4 use cases, right? Case 1 is S of I is 0, S of j is 0. Then the outcome of S of I or S of j is 0. S of I XOR S of j is also 0. Case 2, S of I is 0, S of j is 1. In this case, it's 1 and 1, right? Okay, case 3 is the inverse. S of I is 1, S of j is 0. Same outcome, right? So it'll be 1 and 1. Case 4, S of I is 1, and S of j is also 1. In that case, it's 1 and 0. Okay, so the ones can turn into zeros. If there's more ones, S of j is the XOR. You can arbitrarily choose I and j though, right? It's not like I have. Does I have to be less than j? No, I does not have to be less than j, right? They're just in between 0 and n minus 1 inclusive. Maybe inversion would help. When is it impossible? Correct. Algorithm. Okay. Let's try again here. After thinking about this for a little bit. More coffee. Well, if they're all zeros, then that's true. The ones can be turned into zeros. Oh, maybe if there's more ones than zeros for the other one, then, right? And as long as there's 1 0. Okay, if they're all ones, if they're all zeros, is cool, right? There's no transformation really needed. Otherwise, you have to have more ones than zeros, and you have to have at least 1 0, right? Simultaneously update them. With an auxiliary. That's already 1. That's fine. But this one has to change, right? So that one has to change. So which one do we change it with? Let's call this one I. It's going to be or. Well, it could be either I or J, I guess, right? Okay, those two. Or 1 1. How many mismatches are there? 1, 2, 3, 4, 5. 5 mismatches. try to characterize the problem statement. This is this guy. T is this guy. Mismatch, mismatch, 0. There's 2 mismatches. Or keeps it the same. 1's the same. Okay, as long as 1 is the same, then that can be the I, right? Just keep it the same. And then you flip the other ones. Okay. Okay. Okay, so return true, oops, true, if and only if we have at least 1 digit the same. This will be the ith value, which is ORed, which is a no op, right? I basically keep the same. Then the other ones we can swap. Right, and we have to have 1 to swap it with. And we have at least 1, 0, and 1, 1, 0, and 1, 1, right? Or if all zeros or all ones. Okay, I think that makes sense, right? So if all C for C and S, or C and all C0 or C and T, return true. Otherwise, if they're all ones, we'll return true as well. Wait, there's no transformation. Hold on. So if S is equal to T, all right, return true. Otherwise, we have to have 1 auxiliary and 1 the same. Same equals any S sub I equals T sub I, for I in range length of S, both equals length of the set of the list of characters S is equal to 2, and the same for T. Turn same and both. Right, it has both a 0 and a 1, and there's at least 1 that's the same. Okay, that should be true. Okay, that looks good. Oh, no. Okay, not quite right. Missing something here. Okay, another incorrect algorithm is this guy. Oops. Okie dokie. Let's see what else we got. Not quite right. Okay, so this guy's S. It's expected true, but it returned false. Okay. Oh, this guy has none the same. Oh, okay. Yeah, that doesn't matter then. Right, use deductive reasoning, I suppose, right? Yeah. Right, we don't need same. As one of each. Okay, take this input. It's supposed to be true as returning false. So it's true, false, true, true. True, false, true, true. Big money, no way. Oh, this one's true as well. Really? Huh, wonder if, oh, using inversion. If all of them are opposite, then maybe, right? Inversion based on, I don't know. Let's try using inversion. And what would coach do? He'd use inversion, I think. And based on example 2, we have incidental evidence that all of them are opposite, then it's not possible. Okay, if there's no set intersection, then right. Turn not length, the set intersection, set list S intersected with the set list T. That is not right. It's opposite of what I want, actually, right? Okay, so this guy is expected to be true as well. Oh, man. Just throwing things up on the wall to see what sticks, and so far, not much is sticking. Oh, got my intuition right. Well, found a lot of ways that don't work so far. Maybe I should get some more coffee. Okay, coffee break time. Okay, back to this guy. Music going. Okay. All right, so as long as one of them has 0. Okay, the output was true, but it's a false positive. We want it to be false. It's not possible to transform this into that because we don't have a 1. We have to have at least, if there's a 1 there, we have to have at least a 1 there. So yeah, coach would use inversion, right? When is it impossible to transfer? If there's only zeros here, so only 1's there. It's not possible. Okay, so if all and any character in T is 1. Use inversion. Okay, it has to be false in that case. Right? If they're all zeros, that's that use case. Otherwise, if they're all 1's here, and these are all zeros, we can't do it either, right? These are all 1's. These are all zeros. Turn true, otherwise. Whoa. Bool object is not iterable. Oops. Okay, maybe. Oh, output's true, we expect false. Okay. Or all, these are all zeros, and there's any 1 there. Any. Oops. Oh, well, that's not what I want to do. Any, and this would be all. Anyone's 1, and all these are zeros. Any 0, or all, these are all zeros, and there's any 1 there. Okay. Any 1's and all zeros. All 1's and all zeros. All zeros and all 1's. Does that work? Maybe. Yeah, I think I'm getting close. All right, so this is a false positive. It should be, was true my last attempt, but it should be false, right? So a couple falses at the end is expected. Yay! Yay! First try. Now this is failing forward, right? So that's what we want. And that's what I look for a candidate when I'm interviewing, doing a technical interview. Someone that doesn't give up and keeps trying, right? Keeps failing forward until they figure it out. If you find enough ways that don't work using deductive reasoning and inversion, you can find out a way that does work eventually, right? So there you go. Okay, so I wonder if we can simplify this a little bit though, right? This is pretty ugly. If those are all zeros and there's any one, I think maybe the first two capture everything I need though, right? Yeah, the first two I do. Right, yeah, so the first two capture those second two. So anyhow, yes, use inversion. That's what coach would do. Right, to simplify our lives, we use inversion. When can it not possibly work? It cannot possibly work when these are all zeros and there, and these one there, or these are all ones or any zero there. There you go. Right, oops. Okay. Let's do this. Just turn it into another one-liner. How about? Okay, there's self S and T. Not this and not that, basically. This and not that. Okay, this is huge. It's not really readable. Let's do this. What do we want to call this thing? All zero, all one. Self. All zero. All zero, any one. That works, right? All zero, any one. All one, any zero. This guy. And then this guy will return not self dot this guy. ST XT. And then not T. A little bit easier to read, maybe. I don't know. Oh. All zero, any one, all one, oh, self dot. Looks good. Okay, cool. Yeah, I mean, that looks okay, right? It's not too shabby. It's not a one-liner, but it works. I don't know. I don't know. It's a lot of overhead. We don't really need this print, I don't think. Oops. Oh yeah, we do need that print, right? This guy and that guy, this guy and that guy. Yeah, let's just do this one-liner, whatever. One-liners are cool. Not really that readable, but whatever. Few solutions. Use inversion. Return false when when it is impossible to transform S to T. Just case one. All, let's see, hold on. Three, oops. All characters of S are zero, and any character of T is 1. Case 2, any character of S is 1, and all characters of T are 0. Let's not make this bold, but I like to bold any and all. All. Oh. Any. All. Right. All characters of S are 0, and any character of T is 1. Any character of S is 1, and all characters of T are 0. Right, okay, looks good. It's kind of cool having a contest where you can do all one-liners. And let's see, at 6:30, we have 22 minutes left after this guy. Let's hurry up and get this done. Russ. Be cool to get to Q4, at least take a look at it. Okay, so that's Python 3, JavaScript. Never give up. Never surrender, regardless of how negative people can be. Yeah, I like to take a break and just say, hey, a lot of folks are not encouraging, especially on LeetCode. I lost count how many times I got negative downvotes. Since when has popular opinion known anything anyhow? So it's good to ignore the negativity, focus on the positive, and fail forward. And that's life. Like, things don't work out most of the time, the first time, right? So that's why I'm joking around here. This is kind of like a Lego Batman thing. This first try, right? And since when does it matter if you really get it on the first try? If you're a perfectionist, yeah, it matters if you're a perfectionist, but people aren't perfect. I'm not perfect. I'm part of people, right? So people fast is slow and slow is fast. So just slowly chug along, do my best, fail forward, use deductive, inductive reasoning, and find a good mentor like Coach Vlad. Okay, anyhow, quit rambling, talk is cheap. Let's move on. Okay, so S and T will return false if any of those things, otherwise not S not split not every, so every S is 0, every T dot split sum equals 1, and not S dot split dot sum equals 1, and T dot split dot every C equals 0. Okay, oh, C is not defined. Okay, ends are off by a little bit. Oh, C is not defined. Every, or is it all? Is it all? I didn't think it was all. Some and I thought it was every. JavaScript, some, every, yeah, there's every. S dot split to every. C, oops. C equals 0. Some C. Some C. All C. Okay, there we go. Oh no, this T dot split is not a function. What? Where? Oh, all is not. It should be every. All in Kotlin, all in Python 3. That was good. Oh, no way. Really? Expected false. That's example 2. What did I do here? Let's line this up and debug it. Some, every, some. If this then is false, that then is false. Looks right. Oh, wait. Oops. Got that backwards. Okay. Okay. All right. That was good. Okay, cool. Yeah, it's okay. Just leave it like that. Otherwise, it's really hard to read. So the nice thing about JavaScript is we can put this on new lines compared to Python 3. We're forced to pretty much put it on one single line. So it's a one-liner split across multiple lines, but yeah. That's cool. Okay. Have you Kotlin? Drink some more coffee. Okay. To a lambda, conciseness, because I can. Not s.to char array. All character 0 and t.to char array some, or is it any? I think any. It's 1. Oops. And line this up similar to JavaScript. T.to char array all. Oops, hold on. S to char array dot any. It is equal to 1. Char array all is equal to 0. Okay. Big money, no whammies. Looks good. Yay. Okay. These one-liners are nice and easy to read. Yeah, so nothing too fancy. Rust in C++ next. Okay, we'll save Rust for last. Save the best for last, right? Turn true at the end. Use inversion before that. Or actually, yeah, we can do this in one line, right? Okay, so all of and any of. All of s dot begin, s dot end. Oops. They're all zeros. and any of these ones, any of t dot n dot end. So C++ does have functional programming, right? But it's just like very verbose and kind of an afterthought, pretty obvious. Right? C++ is more meant for procedural programming. Any of the opposite way. All of. Okay. Uh-oh. Not. Not. Okay. Looks good. Looks good. Okay, and then rest. Okay, rest time. Time for rest to give me a hard time. More coffee. Okay. Not and not. S dot chars dot all. Chars any. Chars dot any. Okay. It's good. Oops. Character is equal to that. Character is equal to that. Ooh, okay. Oh, Rust didn't give me too much hard of a time. Big money, no whammies. Yay. Okay, cool. And we'll have a little bit of time for Q4. Q4 is the unicorn. Okay, use inversion, return false when it's impossible to transform S to T. Case one, any characters of S are zero and all right, all characters S are zero and any characters of T is one. Any character of S is one and all characters of T are zero, right? Okay. Looks good. Nothing too fancy. Doesn't have to be perfect. Okay, so we have 10 minutes left for Q4. It's 10 minutes left in the contest for Q4. That unicorn I've been chasing for a while. All right, it's 6:44 in the AM and we are about done. Let's see. Importance. Trend by importance. Return the minimum possible cost of a split. So we're looking for some pivot where we can split it. It's like we can pre-process it and do a linear scan, maybe. Hold on, I gotta go pee. Okay, and we're back. Minimum cost. The objective function is to minimize the cost. We have 10 minutes left. 8 minutes left. Okay, at 6:54, contest will end, right? 6:54 in time. K plus trend subred at length, where all numbers which appear only once are removed. One appears once, two appears once. Importance of value of the subarray will be K plus 5. Because 5 is the length. K is 2. K is 2. So it's 2 times K plus. All right, 2 times K plus. Wait, hold on. No, just one subarray. Subarray is K plus 3 plus 2. Multi-set, okay. Okay, so it seems that we can do some pre-processing. If it's not that large, but K is big. K is a billion. If people fast is slow and slow is fast. So go slow for the next 6 minutes or 5 minutes. What happens if I don't split this thing? You take the entire thing without splitting it. Oops. Take the entire thing without splitting it, then we have 7. 2 plus 7 equals 9. Otherwise, if we do split it, then we want to split it so that we can remove. This is a set, unique set. Okay, so what is the largest unique set? Example 3. This is like, they don't split the example. one array, then we get this, right? If we don't split example 3 array, and then we get 5 plus 5, right? 5 plus 5, right? It's 5 plus 5. Okay, 5 plus 5. But what if we do split example 3? Right, let's just split it based on the first example. Let's say we split it into this guy and then that guy. Yeah, 0 plus 5 plus 2 plus 5, 12. So it really depends on k then. Since k is 5, we pay a high price for splitting. This seems like maybe binary search, right? So what if just guess? Can we perform a logarithmic amount of guesses, each with a cost of a linear scan? We're trying to minimize it, right? So right, the guess would be the pivot, right? Pivot index. I don't know. I don't know if that's helpful or not. Probably may start with brute force. Yeah, what if we brute force try them all? If we try them all using prefix, well, yeah, I don't know if that's helpful. I don't know if that's helpful. So, right, what would a brute force solution look like? And how to optimize for AC? It'll be a follow-up question, right? We have about 1 minute left for brute force. About 1 minute left. Fit index. Okay, so best equals 7. Arbitrary value that's large. I'm not sure if that might not be large enough actually. Let's do this for I. Range A. Actually, what if we don't split it at all, right? So best is how many occur only once? Create counter. Okay, I have 22 seconds left. Yeah, this is the direction I'll go. Okay, brute force, then optimization. All right, this would be the next step. Upsolve. And that Q4 is still an elusive creature I've yet to tame. An elusive creature. Elusive? Elusive? Does that sound like elusive? Yeah, it's an elusive creature. Q4, right? Yeah, Q4 is an elusive creature I have yet to tame. All right, we'll catch you all next time. See ya. It was fun.